This is a map of the frost-free period across Ontario, showing you the average length of the frost-free period, the average date of the last spring frost, and the first fall frost. This is obviously a nice, useful map, but it masks quite a bit of variability. It masks, for example, the fact that the frost-free period is a probabilistic measure. We never know for sure when the date of the last spring frost and the first fall frost will occur. Obviously, we don't know that ahead of time. But what we do know is the distribution, the probability distribution. So what is the probability? What's the probability of a frost occurring after this day or before this day? Okay, and so this matters more. In the spring, we want to know what's the probability of a frost occurring after a certain day, with that frost damaging your crop. And in the fall, we want to know what is the probability of a frost occurring before a certain day. In other words, a killing frost that would harm the crop before it's reached maturity. And so what we're going to do is, rather than rely on this map, we're actually going to calculate frost-free probabilities ourselves. So let's take a little bit of a look at the math involved here. I'm going to go through this in an example. So if this is kind of over your head, that's fine. So let's focus on the spring, right? What is the probability of a frost occurring after a certain day? Let's say, April 15th or May 1st or whatever. That probability is equal to the two probabilities multiplied together. It's the fraction of years with frost, and we're going to define frost here with a temperature, an average temperature below -1 degrees. Okay, so 0 degrees does not count as a frost. Below -1. Fraction of years with frost multiplied by the P of Z is greater than X. We'll talk about that in a second, but the fraction of years with frost is always 1 in Ontario, right? We never have a year where temperatures are always above -1 degrees. Okay, other parts of the world, for example, Spain, that they're kind of, some years they have frost and some years they don't in their cropping systems. So this is important for other locations. But here, Py is always equal to 1. So we only need to worry about this second expression, the second probability. Okay, so we're in Excel right now. And you can see this is a data set that I have from the Aurora Research Station. And it shows daily weather from the year 2000 to 2018. And it's giving you on a daily time step every day minimum temperature, okay, maximum daily temperature, solar radiation, and precipitation. But we're really only concerned with this minimum temperature, which is recorded in degrees Celsius. So, this is the year 2000, and if we go down, this is recording every day until the year 2001, right? So 2000 to day 1 to 366 in the year 2000, and then it starts to 2001, okay? So this was recording probably before you guys were born. Okay, so what we're going to do is basically we're going to calculate the probability of a frost after a given date. And the first step is to record for every year you have data. So I have 18 years worth of data, 2000 to 2018, the date of the last spring frost. Okay, and so one way you can do that is visually go through. I would go through and have to eyeball it, like what's the last day I get a frost. And I'm going to define frost here as when the minimum temperature is equal or less than -1 degree Celsius. So 0 degrees is not a frost. Frost is -1 or lower. Okay, so I'd have to eyeball it and say, okay, when's the last date of a frost? And it looks like it's this day, 105. But that's a lot of work to do for every single year, especially if you have, 10, 15 years. So the easiest way to do this is you go up here, you go to your data tab in Excel, and you click filter. And then you come up with these little arrows at the top, at the first row of every column. So I'm going to go to minimum. And again, we're really only interested in knowing the date of the last spring frost or the first fall frosts. So we're really only interested in days that are less than or equal to frost, -1 degree Celsius. So first I'm going to do a filter, an auto filter here. Okay, so now I've arranged this data so that I'm only showing days that had less than equal or less than -1 degree Celsius minimum temperature. And this is, oh, right here. This gives me the date of the last spring frost and first fall frost. So in the year 2000, day 105 of the year and day 282, between those 2 days there was no frost. But this was the date of the last spring frost and the first fall frost. So I'm going to use this data. I need the date of the last spring frost and the temperature achieved at that date for this calculation. So I have the year 2000. Let me just do the year 2001. I have 2002 to 2018 I already have. But let's finish up with figuring it out for the year 2000. So remember, this is the date of the year, column B. T-min, negative, low, daily minimum temperature is column C. Let me go to the year 2000 and figure this one out. Here we go. Okay, so in year 2000, this was the date of the last spring frost. That's the first fall frost. Let me enter this in. Okay, so, let's say I did that for the rest of the data set, which I already did. I mean, you don't want to watch me just continually doing that. Okay, so we have our data set assembled. So we have for every year in the data set, and you probably want at least 10 to get a good estimation, 10 or more. We have for each year the date of the year where that minimum temperature where the last spring frost occurred. And then I have the minimum temperature. What was the temperature of that last spring frost? And that's just for my own information. You don't actually need this for what we're going to do next, the calculations, the probability stuff. You just need these two things. So let's start. Let me delete this. So first in this calculation, we need the probability of frost after day T. And so T, I'm choosing T to be April 26th. That's kind of arbitrary. So for T, I can't put in April 26th. I need to give the days of the year after January 1st. Okay, because that's how everything's being calculated. Date of the year after January 1st, with January 1st being day 1. And so here I have easily to see April 26th is, what is it? Well, in 2021, because it depends if it's a leap year or not, but April 26, 2021 is 116 days after January 1st. So April 26, I put in 116. Okay, and here you can see, this is where we're doing the data. So average, so the average date of the last spring frost, I actually have to do that, and then average, okay. Okay, so the average date of the last spring frost is 120 days after January 21st. Then standard deviation, so st.dev. So then we do st.devp, and then we also select date of the year. Okay, so we have our average, our standard deviation, and t. And if you look here, x in this whole equation, this complicated thing, it's pretty easy, right? It's equal to, in the numerator, t minus MIF, or average date of first frost. So it's t, which we calculated, 116, minus average date of last spring frost, divided by the standard deviation, which we've also previously calculated right here. So enter, and that is what x is equal to. Okay. Okay, so now we come to the more complicated part of this calculation, finding the probability of p z is greater than x. And so what we're first going to actually calculate is p z is less than x, which is the probability of frost before April 26th, which actually isn't what we're interested in. We want to know what's the probability of frost after that date, but you'll see how we'll get there. Okay, so just going by this equation, I have to start with equals 0.5 multiplied by, and then 1, and it's plus or minus, and you use plus if x is greater than 0, and minus is if x is less than 0. Here x is less than 0, so we're going to go with minus. And then we have the square root. So we have this square root. Okay, square root 1 minus, and then exp, so that is exp, which is, that's the expression in Excel, exp, okay, negative 2 multiplied by x to the power of 2, where is it here? Here we go, power of 2. Okay, so it's x to the power of 2 divided by pi, which we just do pi like that. And that is the end of the equation, I believe. Let's see if this works. Yes, it does. Okay, so this is giving me the probability of frost before April 26th. To get to the probability of frost after April 26th, which is what I'm really interested in, it's actually quite easy. It's just 1 minus this probability, because the sum of those two have to equal 1. So that is a probability of frost occurring after April 26th based on this data set, 64.4%. Okay, let me just highlight that for you, 64.4%. And again, this is the equation that we used. Oop, I want to delete that. And this has to sum to 1. And this is the data set that you need. So you can do this yourself if you have your own weather or temperature data set. Okay, so I just want to quickly go through how you would calculate the probability for the first fall frost. Okay, so first we have to construct our data set, which really we just need year and the date of year of the first fall frost. And I'll just show you how to do it for 2018 because that's the only data point we're missing here. So let me go back to this original data set. Again, I've have the filter on, so I'm only showing days colder than -1 at the minimum. And this is 2018. And let me just see the last fall frost. Yes, so here we go. This is the last spring frost, the first fall frost, is day 287, and it was -1.34. Okay, so just as a reminder, between day 120 and 287, we never had a day with lower than -1 degrees Celsius. Okay, that was a frost-free period. So let me go and, yeah, this is for the fall. Okay, so now our data set of the, this should be the first fall frost. Okay, so again, we have our data here. I'll just make it again. This is the probability of a frost occurring before October 15th. Again, I just picked that date arbitrarily. You go to date of the year, that's 288 days after January 21st. So using our T, again, 288 is equal to T. Our average date of the first fall frost is this number, standard deviation. Perfect. And with that, we can actually calculate X, which is the next thing we need. This is basically the parts of our calculation. So X is equal to, the numerator is that minus that divided by that. Okay, so that's X. And so now let's do the probability stuff. Again, this is kind of well, complicated, but let's just walk through it. So it's 0.5 multiplied by, okay, and then we have this expression here. It's 1, and it's plus if the x is greater than 0, minus if x is less than 0. Here x is less than 0, so it is going to be minus. And then we have square root, SQRT is the Excel function. And this whole rest of the equation is the square root. So we have 1 minus exponent, EXP, in Excel, negative 2 times, and then we need to put this in brackets, x to the power of 2. So x to the power of 2. Good. Okay, all of that divided by pi. So we just write pi in Excel. And then that's it. We just got to close all the brackets here. And hopefully this works. Yeah. So the probability of frost before day 288 or October 15th is 47%. Probability after, I mean, that's not as interesting, but still, it is 1 minus this number. So we have almost 50-50 chance of having frost before or after October 15th, which kind of makes sense because the average date of the first fall frost is 288.57. Okay, so if we just convert, let me just convert these two formulas here, percentages. So you can see it's almost 50-50 split here. If I said, well, what's the probability of frost before October, whatever, let's go day 280, so a bit earlier. Yeah, much less chance of frost. 288 would be, is my math wrong? October 7th. October 7th or 8th. Anyway, so only 13% chance of frost before October 7th, 86% chance of frost after. And, you know, if we go even earlier, let's say, whatever, October 1st, that would be 272. Yeah, very low chance of frost. So you can see, you can play around with this, understand how the probabilities work. And hopefully, you know, this is valuable. Perhaps if you have a weather station on around you, you can use this data and just get, you know, a bit more accurate sense of frost-free days for your own area.